Our first topic in this unit is solving equations with squares and square roots. Okay, so what do I see here? I see that x squared equals 64. This means a number squared equals 64. A number times itself equals 64. So I can think what that number is. It could be 8, because 8 times 8 is 64. It could also be negative 8, because negative 8 times negative 8 is 64. So those are my two answers. Here's what it looks like to use inverse operations to solve. I see there's a squared, and I remember that squared and square root are inverse operations, right? I remember that these square and square root are inverse operations. They undo each other. So if I have x is being squared, I say, oh, okay, I'm going to square root it. The square root and the squared, they undo each other, and I'm left with x by itself. And then if I square root on the left side, I, of course, have to square root on the right side, and that's plus or minus 8, which is the same as negative 8 or positive 8. Now, on the flip side, if I see an equation like this, where x is being square rooted, I say, oh, I see a square root. Let me do the inverse. What's the inverse of square root? The inverse is squaring. So I'm going to square this. Now, if I square on the left, I have to square on the right. So I get x equals, and this is 7 squared. That means 7 times 7, that's 49. There's not two answers here. 7 times 7 is always 49. It's never negative 49. Okay. Let's take a look at this next one. So here, again, I have something that's being square rooted, okay? Now, I'm again going to say, oh, something's being square rooted. Let me square it, okay? So the fact that it's longer doesn't matter. I still need to get rid of the square root first. I notice that here's the equal sign. There's only this thing that's being square rooted on this side of the equal sign, so I'm ready to square, and I'm going to bring down 3x minus 8 without the square root sign. Why? Because the square root and the squared, they canceled. Okay, now over here, I have to do the math. This is 5 squared. So I need to actually do that math, and 5 squared is 25. And now I'm just solving. This we did like very early on in the school year. This is familiar to you. I have minus 8, so I'm doing plus 8. I have x is being multiplied by 3, so I'm dividing by 3. And x equals 11. And notice, again, there's only one answer. Why? Because when I square a number, I only get one answer. Now here, this is going to be different. Why is this going to be different? Because here, I have something squared. So I say, oh, what's the opposite of squared? Oh, it's square root. So I'm going to square root both sides. Now, what's the square root of 64? What number times itself equals 64? Well, the thing is the square root of 64 is actually plus or minus 8. It could be both. So this is where we actually end up with two separate equations, and we're going to get two separate answers. X plus 4 could equal negative 8, or x plus 4 could equal positive 8. And then I need to solve. I still need to get x by itself, right? I'm not done. And then careful here, negative 8 minus 4 is negative 12. Positive 8 minus 4 is positive 4. So I get x equals negative 12 and positive 4. Okay, and in this last problem, something really specific and important to notice happens, which is here's the equal sign. Look, in all of these problems, I had something squared, and that was the only thing on this side of the equal sign. Something square rooted, that was the only thing on this side of the equal sign. Here, look, see how this thing is being squared? And I'm going to square root to get rid of it, but first, this is not being squared. So first I need to get rid of this. So I'm going to subtract it from both sides. That doesn't change anything else. Look, notice that only eliminated the 5. It didn't change any of this. Okay, and now I see, oh, I have something squared. I'm going to square root both sides. So that means 2x minus 7 equals the square root of 9. Look, it's not 81. Okay, this is not 9 squared. This is the square root. This is plus or minus 3. Okay, so now what does that mean? That means 2x minus 7 could equal negative 3, or 2x minus 7 could equal positive 3. And I need to solve. Negative 3 plus 7 is 4. When I divide by 2, I get x equals 2. Positive 3 plus 7 is 10. And when I divide by 2, I get 5. So x could equal 2 or 5. And I'm just going to check my work really quick. Look, what if I plug in? This is 2 times 2. That's 4. Minus 7. That's 3, right? So this whole thing is 3. 3 squared is 9. plus 5 is 14. Perfect. And then what if I plug in 5? That's 2 times 5 is 10. When I did 2 times 2, that was 4, minus 7 was negative 3. Look, now this 2 times 5 is 10, minus 7, that's positive 3. Either way, when I square it, whether it's 3 squared or negative 3 squared, I get positive 9 here, which is perfect because 9 plus 5 is 14.